In this video, we're going to look at using the discriminant to tell us about the solutions to a quadratic equation. Now, the discriminant, by definition, is only the part of the quadratic formula that lives under the radical. So the part under the radical is just going to be b squared minus 4 times a times c. When we're using the discriminant, we're not actually solving for x. What we're doing is we're looking at one component of the quadratic formula, and that's going to give us a map on how we can solve this problem. Okay, so when we're looking at the discriminant, we're looking at the values that we get for it. And so I'm going to create a chart here on the screen. All right. When the discriminant is negative, doesn't matter what the number is, if it's negative, we cannot take the square root of a negative number. So when we think about the solutions, okay, so this is the discriminant side. And we want to think of when the solution is negative, that means that the number of solutions that we're going to have is going to be no solutions. No real solutions, because we cannot take the square root of a negative number. Okay? When the discriminant is equal to 0, that means that we have one solution. One solution. And then when we have a positive discriminant, that means we have two real solutions. So if we're looking at a problem and we want to figure out if we even need to do anything to solve it, we can look at the discriminant first, and if we can show that the discriminant is negative, we can stop and say there's no solution and we don't have to continue. If the discriminant is 0, then we know we have one solution. Positive means two real solutions. Now, if the positive discriminant is a perfect square, if it's a perfect square, that means that our quadratic can be factored. It's factorable. We also know that if the discriminant is 0, that is also factorable. If the discriminant is not a perfect square, like for say 29, then we know that we can't factor the problem and we would have to use the quadratic formula. But if we're solving for the discriminant, we find that it's something like 16 or 9 or 25. Those numbers we can take the square root of, and that means that we can factor this problem. Okay, so let's try a couple of these. I have 4 examples on the screen here. The first example is 2x squared plus 4x plus 2. So recalling from the previous screen, the discriminant is going to be b squared minus 4 times a times c. Okay, this is the discriminant formula. In the first example problem, b is 4, so I'm going to do 4 squared minus 4 times a, which is 2, and c, which is 2. And I can put that in the calculator. So I get parenthesis 4 squared minus 4 times 2 times 2. And I get 0. And then for a call from the previous screen, when we have a discriminant that's equal to 0, it means I have one solution. One solution. Okay, again, we're not solving these problems here. All we're looking for is to interpret the discriminant and let it tell us how many solutions our problem has. Okay, in the second example, we have x squared plus 3x minus 5 is equal to 0. And then setting up the discriminant there, we get b squared, which is 3 squared, minus 4 times a, which is 1, and c, which is negative 5. Again, this is calculator work here. You can do this in your head if you want, or the long way, but I choose to use a calculator, and I get 29. Okay, 29 is a positive number, which means we have two real solutions. And it also tells us, because 29 is not a perfect square, that this is also not factorable. Okay, not factorable. Meaning we don't even have to try the magic X to see if we can factor it. We know right off the bat with the discriminant, not factorable. Move away from factoring, goes straight to the quadratic formula if we were solving. Okay, the next problem, 8x squared minus 5x plus 5, setting this one up. B squared is going to be parenthesis negative 5 squared minus 4 times 8 times 5. Okay, setting this one up in the calculator, we get negative 5 squared minus 4 parenthesis 8, 5, and I get negative 135. Remembering from the table, negative means no real solutions. No real solutions. Okay, last problem, 8x squared minus 8 is equal to 0. Setting up our quadratic formula for this, or not our quadratic formula, excuse me, our discriminant, we get b squared. Now notice, there is no x term. I have 8x squared and I have negative 8, but I don't have anything in the middle. And so when that happens, we can really write this as 8x squared plus 0x minus 8 is equal to 0. Because I don't have an x term, that means the coefficient has to be 0, making b also 0. So setting up the discriminant here, I get 0 squared minus 4 times positive 8 for a times negative 8 for c. So I'm going to type this in the calculator exactly like it's written, because I don't want to make an error with signs or anything like that. And we get 256. Now, if you want to see if it's factorable, because we did get a positive number, we can try to take the square root in the calculator. And notice when we do that, I get a perfect number out, meaning that this is in fact factorable. So not only is it two real solutions, it's also a case that's factorable, meaning I can try to set up the x and get my solutions using the other method. Okay? That's using the discriminant to interpret the number of solutions for a quadratic. All right? All right, good luck.